Hello and welcome to this video from the P7 series and this section on stars, and this video is called Stars and Space. And in this video I'm going to talk briefly, and this is going to be a short one, briefly about what we see when we look out into space and look at all the other stars that are out there. So obviously we've spoken about people having done that before to try and understand the size and the shape of different galaxies and trying to work out the arrangement. But one thing we've also done is try to look at the different types of stars and to classify them. So these are questions like how big, how bright, and how hot are other stars. And by doing so, by having a look out into space and seeing all the different types of stars, we can then try to work out how stars change over the course of their lifetime. I mean, it's very hard for us to look at our sun and think about what might happen to our sun in the future, because it's doing the same thing. It's been doing the same thing for thousands of years as far as we can tell. But excuse me, but if we look at some other stars, we can maybe get an idea about what the future holds. So this idea was a popular one, and there were a few different scientists working on doing this sort of thing. And we had in Europe, we had a scientist called Hertzsprung. Oh, sorry, Mr. Hertzsprung, I think there's an S in your name. Hertzsprung, who was a European scientist, and there was also a scientist, an American called Russell, and they independently or separately did the same bit of work trying to classify stars in terms of their luminosity and temperature, and this is what they came up with. They plotted all these different types of stars, the information that they had on these two axes. Now on the y-axis here we've got, this is luminosity, so if you're up high on the graph you're very luminous, that means you're giving out lots of light each second. And if you're down near the bottom, you're quite a faint, dim star, not giving out that much light. And on the x-axis here, cold stars or cooler stars are on the right-hand side, and as we move towards the left, we get hotter and hotter and hotter. Now, here's the sun, and the sun, with the temperature of it and the amount of luminosity that's giving, is quite an average sort of star. And it appears in this whole section here, which we would call the main sequence, and the vast majority of stars appear inside this main sequence. There are a couple of other regions where you find stars. We've got some stars down here which are called white dwarfs. So these are very hot, but they're actually quite faint. The reason for this is because they're small. They're very small stars, so they're very, very hot, but because they're very small, they don't actually have a very large surface area, so they give out a small amount of light per second. And then up here we've got supergiants, really, really massive, huge, huge stars, but they're not quite as hot. They're quite cool, but because they've got such a large surface area, they're giving out huge amounts of energy per second. So there's a few different types of stars and star groups that we find here, but this main group here is this main sequence, and if we count up how many stars belong in these different groups, the vast majority of all stars exist on this main sequence. By looking at the number of stars and star populations and seeing them in different groups in different places, this has helped us to work out that, well, what we think happens is that stars begin their life on this main sequence and they spend the majority of their life there. I mean, it makes sense if the majority of their life is spent on it, because the majority of stars in our universe are on it right now. But then later in their lives, they either become white dwarfs or supergiants, or some other section, some other part of the life of these stars. But this is the HR diagram, named after our two scientists, Hertzsprung and Russell diagram, and it is used, and it's useful for us to classify stars and to see the general patterns of how their luminosity and temperature are related to each other. As well as the stars that we're looking at, and this is how we classify stars, I've also put here that we're looking at space, because we've obviously got lots and lots of stars out there, but what is in between the stars? So in between the stars we have space, Or is it empty space, or does it contain gas, or what exactly does that space contain? Well, in my picture here, we've got a picture here. This is of a nebula. This is actually called the Rosette Nebula because it resembles a rosette. And this essentially is a big cloud of gas and dust. And so each of these tiny dots on here is a star, but in between the star there is actually some stuff. When we talk about space, it's a bit of a misleading term because you think about space as having absolutely nothing in it, but to have an area that contains absolutely no particles whatsoever is actually very difficult to come by. And inside parts of space we do have bits of dust, we've got rogue particles and protons and little bits and pieces floating around, and anything that is in between stars we actually call the ISM, which is the interstellar medium. So interstellar, that means between stars, and then the medium, so that's the stuff that is between stars. So there are parts of the interstellar medium that are almost a vacuum, that have a very, very, very low density indeed, hardly any particles at all, but then there are other parts of the interstellar medium that do contain actually some stuff. They do contain some particles somewhere within it, in between those stars. On Earth, if you had 1 centimeter cubed of air, you would find inside 1 centimeter cubed of air, you'd find 10 to the 20 particles, a huge, huge number of particles. So that's 10 but then with 20 zeros on the end, etc., all the way having 20 zeros. But there are regions of space where you'll find within 1 centimeter cubed, maybe you'll find hundreds of particles. So in comparison, or maybe, really, really low density areas of space, maybe even 1 particle within a centimeter cubed. So there still is some stuff in the interstellar medium, but nowhere near as much as there is inside on Earth, or inside the conditions here in our atmosphere. And something that we're going to have a look at over the next few videos is trying to relate the amount of stuff, what's in there in these gases out in space. We're going to be linking the gases, the pressures, the temperatures, and trying to understand how the relationships between gas, pressures, temperatures and volumes, how they come together and how these physical factors affect the behaviour of stars. And by hopefully understanding things to do with pressure, volume and temperature, we're going to then get an idea about how we can go from having a big cloud of gas like the one in the picture shown, where all this gas actually ends up coming together to form a star.
Now it's time for our wrap-up. Let's give it everything we've got. Ready? Begin.
So a very brief summary here. In this video today we looked at the Hertzsprung-Russell diagram. It's basically a diagram that has been put together to help classify stars. We've got luminosity on the y-axis, temperature on the x-axis, but here look, one thing to notice, this is cool and this is hot, so temperature is decreasing on the x-axis. The majority of stars in the universe exist on this main sequence, and then there are some other smaller groups, and this is used not only to classify stars, but it's helpful for us to work out where stars have been and where they're going. Also, within space, well, between the stars, we have space, and I say that in inverted commas here. Actually, it's better to call it the interstellar medium, because there is stuff between the stars. It's not completely empty, it's not a complete vacuum devoid of anything whatsoever, and this interstellar medium and the behaviour of the gases within it can have a consequence for how stars form. One other thing here, this is just the Hertzsprung-Russell diagram just explained and made absolutely foolproof here, showing that obviously if the sun is in the middle, compared to the sun. Obviously up here we've got cool luminous stars. I don't need to explain this, this speaks for itself. But that's it for looking at stars and space, and onwards we're going to try to understand a bit about how gases behave and the laws of gases, so that then we can properly understand how stars form.